right, we're at the APUS Observatory. I'm just going to go through general information about the observatory, the dome, the telescope, other facets, both just so you know what things are, and in case you need to do any maintenance. The wall that we're looking at right now is for dome control, sort of as it says in the box. Over here to the left, we've got the main power cutoff. We're in the off state, so nothing will work with the observatory right now. I'm going to go ahead and power it on. So now we have power. There's also an on-off switch here at the main box. This box will control rotation. So I can operate rotation here. I can also operate the shutters. The next set of switches up is for handling the shutters. In sequence, if I leave it on sequence and hit open, it'll open the upper shutter, then the lower. And if they're open and I hit close, it'll close the lower, then the upper. Or I can select which one I want. In this case, I can select the upper or the lower. Just remember, the upper has to be open part of the way before the lower can be open, because the lower shutter overlaps the upper. The next switch up here is really important. It is remote or local. Should always be in remote unless you're doing some work physically with the observatory. Remote means I can control it through the computer. Local means I can operate it here. If I'm here and want to operate it locally, let's say we want to rotate the dome left, notice nothing happens. It's got to be in the local switch to do anything in the observatory. So now if I do it, we can rotate the dome back and forth. Same thing here. I can open the shutters. I'm going to put it on just upper right now. And we can look over here and see the shutter opening. And then if I want to open the lower, I flip it to lower and hit the open button. Right now it's doing both because there's another box over here on the upper shutter, or shutter control box. It's set to sequence, so it's actually taking precedence over the box that I'm working on. So the only way to change that is to actually go up there, and we'll do that here in a second, and flip that to upper or lower. And I'll do that. I'll close them from up there. So I'll flip this back to sequence, and we'll come over here and take a look at this box. This is the shutter control mechanism. Very similar to the box we're just on, except there's no rotation ability. Again, if I'm going to operate from up here, I need to be on local. So I can flip it to local, I can flip it to upper, and there we go. I can open it on the upper, I can then flip it to lower, and just open the lower. And because I was not in sequence, I can control from this box exactly which ones, or which shutter I need to operate. Again, close, I'll do a close here. The shutters, both the upper and the lower, have limit switches, meaning when a shutter gets fully opened or fully closed, it will automatically stop, even if you still have your hand on the button. So if we close the lower shutter, I'm still holding closed, but you heard a click. It's not going to operate anymore. This unit right here is the hydraulics for opening the lower shutter. It also has a bypass valve, so if anything happened, the proximity switch didn't cut the motor right away, the bypass valve would kick in, and you're not going to get an overpressure situation where hydraulics are continuing to try to open the shutter or close it when it can't be either opened or closed. Let's go ahead and go back to upper and then close. And when it gets fully closed, again, the limit switches will cut things off. There we go. Just remember, when you're done, you want to put this back on sequence, this back to remote. If you do need to cut the power, just like in the other box, you can cut the power by turning it off. They are independent. Turning this off here only turns off the shutters. It does nothing with rotation motors. So the best way to cut power is to do the main disconnect. These orange slip rings right here transfer power from the base ring that doesn't rotate to a dome that does. Way over on that side, that red sort of piece of metal behind it are actually fingers that rotate in these tracks and send electricity into the tracks. And then right over here, that little box right there pulls electricity out of the tracks, sends it up to the radio control unit, and then over here to the main shutter unit. These two wires here are radio control. In other words, they send signals or get signals from that box down there and anything that we're doing remote control wise up to the shutter. So it sort of prevents the shutter or the upper shutter box from ever being blocked by the telescope and not being able to receive a signal. So there's a little wire right here, connects into this box, you can see it right over there, and then this wire here connects over there into the main control box. There's also shut-off. Ash puts those little boxes with the red handles in them for cutting power to motors. I'm not exactly sure why. There's one of them, like on the upper shutter, there's one way up there. You'd never be able to reach it. What we're looking up there, that is the upper shutter motor. You can see it hanging out the back. There's a gear in there that's going in the gear track for moving the upper shutter. There's also, you can see an eye screw up there, and then over here on the floor, we have a handle with a hook, and I believe this one down here is an extension bar. Basically, if you take this and with the extension bar and get it all the way up there, you can turn it like this and manually close the upper shutter. So if there's a major power failure or the motor burns up, don't know, you can close it. That's part of the essentials for the dome. The telescope we're looking at right here, it's on a big pier. Coming around the side here, this cable right now sends power up to the telescope, both the motor and all the electronics on there. The switches for turning them on are up at the unit. We're talking about adding a remote internet power switch so they can control through the internet or through the web, either probably the network here at the campus, but that's not in place right now. So, to actually turn on the telescope, we've got two things that need to be done. First, I'm going to climb up. You see a little black box here at the base of the telescope. This powers the mount. So if I flip it on, we get little red lights, and it's quiet. You don't hear anything. So there's no indication other than the fact that the red lights are lit that power is on. Harder to get to, and see if I can get to it from where I'm at, is this power strip right up here. And a little switch, and you'll see the switch turn red. You also hear things. So as I back out a little bit, the fan's going on both of these cameras. I can see a red light over here. There's blue, there's the USB connections up there, everything's powered up. So that is all through one switch. if you ever need to move the telescope, there are manual clutches for doing that, but unless you know what you're doing, I wouldn't release them. You can move it through this hand controller. So, for example, if I hit the down button here, see how the telescope's spinning back and forth? Up goes the other way. And then if I want to go side to side, if you ever accidentally hit the button in the center, that just changes the speed. So we're going pretty fast. If I hit it once, I'm on a slow speed. So now I'm still moving, but you just don't really see it. If I hit it again, you're going really, really slow, and you really won't see it. And then if you hit it a third time, you're back to being fast. So it's easy to do accidentally hitting it if you're looking at the scope, trying to make sure you're going in the right direction and trying to hit buttons with your hand. But that is up here. That just plugs in right here on the unit. Everything else is all set up, ready to go. So there's nothing really to change on the telescope itself. Sometimes telescopes have covers over them because this is in use all the time, or intended to be in use all the time. The covers over the mirror are not in place. So we've got, so we can see up there a spandex, what they call a light shroud, that keeps stray light away and dust off. We estimate that the whole telescope system weighs about 800 pounds. So it's a beefy item. Over here in the wall, for looking into the observatory while it's in use, since people aren't in here, we have an observatory webcam. It's connected into the internet here. All of this can be controlled through the observatory computer. In other words, we can change the angle that the webcam is looking at. It also has infrared capability, so at night, even when the observatory is totally dark, you easily see the telescope and the movement that it's making inside the observatory. When you're done, if you have to do any work on the telescope, move the ladder out of the way. There's probably certain angles that telescope can be in that will put those cameras right at the very top of the ladder, and maybe even hit them. And in the front, those counterweights that stick down will hit the ladder. So whenever you're done, move it over the wall, out of the way. I would recommend getting it into a wall probably over in this area, just because we want the observatory, we don't want it to block the camera, or else people can't see what's going on. Okay, we're out in the roof. We're taking a look at essentially the weather setup and monitoring stations for the observatory and for the campus in general. Over here on the left, we have Cloud Watcher from Technical Innovations. Essentially, this measures sky temperature. Clouds reflect heat. No clouds let heat escape to outer space. So it monitors. Right now, it'd be detecting a lot of clouds, and we can use that to automatically close the shutter on the observatory, which you can see the top of right over there, automatically. And at least we can monitor what's going on. It also detects rain. So if it even gets a light sprinkling, it should be able to trigger a closed condition. And it's at an angle. There's a heater built into it, so during the winter when we get snow, the heater will melt off the snow and keep the sensors open to the sky. To the right of the cloud sensor is an all-sky camera. This comes from Santa Barbara Instruments Group. It's a high-quality CCD camera that lets us continuously take pictures of the sky, and it faces straight up. It's got a 360-degree wide field lens, so it should be taking pictures down the horizon. Mostly it's for just giving us an idea of what kind of cloud cover is up in the sky. It doesn't do anything automatic with the observatory, but can be used for research. In other words, we can process the video after the fact and then maybe look for meteors or passing satellites, a number of different things. And then over here on the far right, we've got two things going on. That's a Davis cloud sensor. This whole system comes from a company called WeatherStem. It's a Davis cloud sensor up there, so we're getting readings from wind direction, rain, a lot of different things, and that's all fed into a website that we can display. And then just below that is what they call like a cloud watcher camera, pointed more horizontally, a little bit up, but more horizontally, facing towards the observatory. That just gives you an outside picture of what's going on with the sky. Not as high quality as the all-sky camera, but it'll give you a good representation of what you're seeing at any one time. All of this is cabled through the opening here. It goes back through the wall and then somehow gets over to the computer room. Inside here, we've also got power cables, so there's power needed for the cloud watcher and also power for the all-sky camera. They're coming up to these cables, and then these are both data coming back down from Davis and also from our cloud sensor and our all-sky camera.